Excuse me, sir. Yesterday in the morning session, up to Riemann sum was actually discussed.
Okay.
Can you discuss the balance concepts and then continue from there?
Sorry. Can you repeat it again? What do you want?
So the concepts up to Riemann sum was actually discussed yesterday
Okay.
for the week 9. Can you do the balance of that concepts from the week 9 from after Riemann sum?
Okay. I will try. So basically in today's session, what I will do, I will take your doubts from week 9 and then we'll try to resolve. Okay.
Yeah.
So whatever you want, if you want to recall that concept, then I will do. And if you have some doubts on the practice assignments or graded assignment, sorry, not graded assignment, on practice assignment, or if you want some hints from graded assignment, then please let me know. We'll try to resolve it. And yeah, if you want, you want to explain me those things after Riemann sum, right?
Yeah.
Wait for a second.
Sir, can you give summary little bit
Yeah, we'll try.
for week?
Okay. Okay, so shall we start the session? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so before starting the session, I'm just casually asking to you guys, do you have any doubts on week 9?
Yes, sir. In activity.
Okay. Please paste that question on chat box and then let me know what doubt you have. Then after that, we'll cover that topic, whatever is remaining. Okay.
Okay.
So I just wanted to confirm for quiz 2, we'll be having week 1 to week 8, right?
Yeah. They mentioned that thing on your NPTEL side or whatever. Do you have? I guess what is it? Just a minute. They already mentioned that thing, right? On NPTEL side, online degree ITM site, c.online degree ITM.ac.in.
I'll
On
check
the
it.
grading document.
Yeah.
Okay, it's in the grading document, so it's from week 1 to week 8. All right. Okay.
Yeah.
Thank you. And do we have, like last time we had revision sessions for quiz 1, like for the qualifiers, and
Okay.
there was some old PYQ question discussions also. So do we have it in the lineup for the
So
upcoming?
from when your exam will start?
Uh,
3rd of the December.
yes, 3rd December.
3rd December. And what today? What?
26th.
Today is 26. Okay, so if there is some revision session kind of thing, then they will inform by me.
Last time Vishal sir has told that the revision session are also lined up for this week.
Yeah. If there will be some session, then we will let you know. Okay.
Sir, do you know like how the final grade is calculated?
No, I don't have any idea about it actually.
Okay, sir.
Sir,
That's in the grading document.
There are different
That's also in a grading document.
Sir, there are
Yeah, that is like it will take all the Q1, Q2 and earn time together, and then there's a formula that is being applied. So it's not just about enter and mark. It's about all three. But there is a degree of, I mean, there is a difference in the how much weightage is given for each exam.
Are you able to see both the screens? One is your slides and all, and then another one is one note screen.
Yes, sir. Yes, sir. Yes.
Okay. Okay. So if you have some doubts on practice assignment, then please paste here. We will try to solve it. We will together try to solve it. Otherwise, I will start whatever is remaining on those days.
Sir, we will have paste full questions. Yeah, only question number.
You have to paste full question. Otherwise, I have to again open that one and then take a screenshot, and then it's a long process. From here, I will directly download and then paste.
Okay.
Sir, can you explain this question? Which one? Others? Oh, first of all, good evening, guys.
Good evening,
how is
sir.
going?
Good evening, sir.
So how is going your preparation?
It is good now, sir.
Good.
Good. Okay, others will take this. Okay, we'll take this. This question is coming from I guess week 7 or week 8, I guess.
Week 7. Yes, sir.
So what this question is asking, consider you have a sequence in which following this kind of recursive relation. Okay.
Yes, sir.
Which of the following is correct? That is that this is already solved, I guess.
No, sir. I am not able to understand.
Okay. Okay, we'll take this. Okay, this is not the toughest one. This is easy. We'll take this in the last. Is it fine for you?
Okay, sir. Okay. Yes, sir.
Please remind me. Okay.
Yes, sir. Yes, sir.
Okay. Okay, so we'll start the session. Someone wants to paste their doubt on a chat box, please. Is it fine?
Yes. Yes.
Okay. So after Riemann sum, right? So before starting that definite integral part of that definite integral or Riemann sums, you have to know about some definition and all. Okay. So firstly, I will explain those things, whatever it is. Okay. So here are some definition. That thing you already learned, I guess. Right?
Yep.
This thing. What is Riemann sum and all. So can someone quickly tell me what is Riemann sum and all? Like before starting the Riemann sum, first of all, you have to know about what is interval. Okay. After that, you have to know about partition of an interval. So do you have any basic idea why we are doing this kind of stuff? Riemann sum and all.
To find the
And what
area
is
under
the
that curve.
motivation behind it? Sorry.
Find the area under that particular interval in the curve.
Yeah, that's the another reason. That's why we are doing this kind of stuff. And do you know why we like how Riemann think like that we can do this thing? Do you have any idea regarding that?
Sir, I didn't understand your question.
My question is how Riemann thought that kind of process. How he has think like that ki now if we will do by this manner, so we will able to solve the area under the curve.
Because of sir, we Raymond's like familiar with the area of rectangle, like then previous lectures sir says, and the help with the help of rectangle area we find other than area other uh, areas of
Okay.
things like.
So basically what thing is going on now? My first question is, how do you know that suppose you have a rectangle, this its length is a and width is b. So how do you know that the area of this rectangle will be a dot b?
By integration. Yes.
By
Radius rectangle.
integration. But right now, suppose that you don't have any idea about integration till now. You don't know what is integration till now. So how will you think like that? How will you find the area of this particular rectangle?
It will be like if you divide this by 1 unit and then
How will you divide?
Partitions.
partitions here.
Partitions.
How will you
We make
partitionate
a
this?
we make a simple small partition and measure the area and multiply with the big area
Yeah, that is
we
another
want.
reason. Yeah, that is the motivation. Okay, so let me explain what thing is going on here. Okay, suppose you have a line. Suppose this is your line. Okay, this is not looking like a line, but suppose this is a line. Okay, and the length of this line is suppose some k unit. Okay, the length
Okay,
of
sir.
this line is k unit. Now, if I will put one line over here, like this is there is no gap between these two lines. This is just one line. Also, the line has same k unit. So now, if I will ask you, what is the area that these two lines has covered?
That will be K.
It will be like there is two line with k length, right? One line cover k unit. The another line is covering k unit. So both two line will cover 2k unit, right? Right? What I am
Okay.
saying, one
So
line
no, it's
is
not overlap.
covering k unit area because the length, what in the one dimension case, what is the area of the curve? The length of the line or the length of the curve, right? In one dimension case. What I am
Sir.
saying, suppose you have only one way to go. Okay, this is the only one way where you can drive. Now either you can go by this way or you can go by this way, right? Either this or this. If I will
Yes.
ask you how much distance will you have covered, the length of this line. So basically,
Yes.
if I will ask you how much area you have covered, so this line, the length of this line only.
Yes.
Okay, so I am saying ki you have a line AB. This is line segment. Okay, you have a line segment AB, and the length of this line segment is K. And again,
Yes.
my condition is I am again putting a line, another line over here, such that there is no gap between these two lines. If I will ask you
Yes.
what is the area under these two lines, covered by these two lines, so it will be k area this up to k unit area this. This is what 2k unit,
2K area.
Yeah.
Yes.
Okay. Yeah.
right? If I will
Yeah.
put one more line here, so how
That is
How
3K.
will you get?
3K.
That is
3K.
3K, right? Now, here what you can do? You can split it as a line. See,
Yes.
right? So there are total, how many lines? P lines are there.
3 lines.
Okay, I don't know this B is coming from natural number or not. I don't know, because here uncountably many lines are there. Okay, I don't know that thing. But whatever it is, the thickness of this particular thing will be B. Okay,
Yes.
so
So we can also
if I
take
will,
a small elephant as a dx.
yeah, that we can take. But I am just giving you a motivation how we can find what the motivation behind the area of rectangle. We can also take, but that is an advanced version of particular thing. Okay, but in the initial state, how will you think? Okay.
Yes.
Yes, sir.
Understood?
Yes, sir.
But in the initial state, how will you think? That is that's what I want to explain that thing. Okay, so basically what is going on here? I am putting one line over here so that the gap between these two lines will be zero, negligible. Okay, and not zero but tending to zero. Understood? So how many lines are there? I am assuming that are B lines. Okay, so same as it is like here, what will be the area covered by this rectangle? It will be B times A or A
3
times
times.
B. Okay, understood?
Understood.
Understood. So this is the motivation behind the area of rectangle. Okay, now now the thing is how Riemann think like that. Suppose you have everyone, like most of the person are coming from village area, and they have some land and all, right?
Yes, sir.
Right. All
Yes.
of you guys has seen the land kind of thing where you can grow agriculture, where you can do some agriculture and all. So the shape of that land is not specific. Sometimes they are like this, and sometimes they are like this. Okay, so basically the shape of the land is not fixed, right? So on that time, it's difficult to find the shape of that particular land by directly multiplying the length and width and all. So one person is coming known as Riemann, and he has given, before that another person was there, the now no name was Darbox, and I don't know what is it exactly name, but there was some Darbox kind of thing, and he has given some criteria about that. So he told that if you have some curve like that, now this is the one curve only. If you will go to the higher mathematics, there will be a term of Riemann strategic integral equation, where you can you will be able to find the area of this particular thing. Okay, so here basically I will talk about this area under this simple curve. Okay, so how will he think? How he has thought? How will I motivate? So he knows that thing. I can find easily the area of rectangle. Okay, so what he did, he split this curve to rectangle. So from now, if he wants to split this, so he has to put like this. Okay, so let
We have to put a
draw
small
a smooth
strip.
curve. Sorry.
We have to put a small strip
Yeah, that's what I am
to
doing.
cover the area.
That's what I am doing. What I am doing basically, I am taking this in a specific curve so that you will easily understand what's going on here. Okay, so what I am doing, I am taking some. Okay, before starting this, I will explain what is partition. Okay, so suppose you have an interval. Okay, and I am taking some independent points from this interval known as, suppose, x0, x1 up to xn. So what is the speciality of this point? The specificity of this point is, here your x0 will be A and your xn will be B, and then these all xi's should be lies inside this. Okay, for all I. Sir, how to find for B subdivision? Swarnim, can you unmute yourself and then tell me your doubt, what you have?
Sorry, sir, not in this. This is for a picture that I have put in the chat, sir. Not for this one.
Okay.
Sorry.
I will take your doubt. Okay, fine. Okay, I will take you one by one.
Okay.
Okay, so what I am doing, I am taking some n point between this interval, and the condition is your x0 should be A and xn should be B, and all are the xi's between x0 should be between x0 to x1 for all I coming from 1 to up to n. Okay, so this kind of set P, x0, x1, xn, is known as partition of AB. Okay, why I am telling it's a partition? Do you
Because
have learned
it is
about partition of a
dividing,
set?
sir.
Do you have learned about what is partition of a set?
No, sir.
No. Okay, so I'll give you a small example.
So
Okay,
Cartesian
suppose
product.
no,
is
partition, not Cartesian product. I'm talking about
okay.
partition. Do you have heard about this particular word, partition?
Yes, sir.
Suppose there is a one big family is there. Okay.
Yes, partition in families and in property
Yeah,
like
exactly.
this.
Yeah. There is one big family, and they have some 50 acres land. And in this big family, there are 5 brothers. 1, 2, 3, 4, and 5. Now, their father was died, and now they have to partition this 50 acres land. Okay, I don't know how method they will apply to partition this 50 acre, but the thing is, whatever land this person will take, this person cannot take, right?
Yes.
Right, what I am saying, whatever land this person will take, this person cannot take. Similarly, whatever amount this person will take, these 4 person will not take, right? But
yes.
if I will combine all the land of this 5 person, you will get this 50 acres land.
Yes.
So basically what I am doing, suppose you have a subset S containing some element A0, A1 up to A2, AN, okay, and you are taking some subsets of this set A, B, C, okay. Now if I will say this subset is a partition of this S, if and only if, first of all, intersection should be empty. This is just a reference, okay. And what else? Similar as one, whatever land this person will take, this 4 person cannot take, right?
Yes.
Similarly, whatever element this A will take, this B and C will not take, according to this motivation.
Yes.
Okay.
Yes.
Similarly, whatever element this B person will take, this person cannot, sorry, A and C cannot take. So that thing I have written, the common element will not be there, right? A and B will be empty, B and C will be empty. Sorry, the intersection of A and B will be empty, the intersection of B and C will be empty, and the intersection of A and C will be empty, right? And another condition is A union B union C is equals to S. Same as here, when I will combine all the properties that they have distributed, you will get this 50 acres land, right?
Yes, like equally likely condition.
Exactly. So suppose this A person have taken some value, this B person has taken some value, and this C person has taken some value. So what are the value they have taken? If I will combine all those value, you will get S.
Yes.
Okay. So now similar in a similar way, suppose this is also your set, right? AB.
Yes.
This AB is also your set. Now I am just saying, take a collection P such that x0, x1 up to xn, where your x0 is what? A, x1, sorry, x1 whatever it is, I don't know, but xn is your B, and this all the xi's are coming from this x0 and xb. So what you are taking, suppose this is your A, this is your B, this is your interval, and this is your x0, this is your xn. Now you are taking this point. This is your x1, this is your x2, this is your x3, x4, and all. Okay, so what I am doing, I am taking this point, this point, this point, this point, and I am saying take this, this. So this, if I will take this particular thing, this is also a partition, right?
Yes, sir.
Right? Because if I will take intersection of these two, you will get empty. Because I am taking open here. Okay. Similarly, if you will take intersection of these two or from anywhere else, you will get empty. And if you will combine all those things, you will get AB again.
Yes.
Okay. So in this case, I will not write the subset A, B, C. I am just taking this x1, x0, x1, x2, x3, xn up to xn this point, and name is partition P, and saying that yeah, this collection will be a partition of this. Understood the logic behind partition?
Yes.
Everyone?
Yes, sir.
All of you 25, all of you guys from 25 people. Okay. Now here you have heard about partition. Now, if I am doing partition here, suppose in this example, if I will do some partition, so there will be some person, if partition will not be uniform, so there will be some person. Uniform, it means that each person should have equally likely length. Okay. Every person should have equal length. 10
Yes, sir.
acres. Understood? So if they will not have equal length, so there will be some person, suppose that is 3, number 3 will have maximum length. Okay.
Okay.
There will be some person who has maximum length.
Yes.
Similarly, in this example, there will be some subset A, B, or C who has maximum number of element of S, right?
Yes, yes. It can be.
Similarly, if I will see here, this is what this is showing. This is showing distance between x1 and x, the length of this subinterval. This thing is showing the length of this subinterval. So there will be some subinterval. Okay, this xn minus 1, xn is known as subinterval. Okay, because this is your bigger interval, or you are taking a partition of one particular subinterval. Understood?
Yes.
Okay, so every if the partition is not uniform, there will be some subinterval who has maximum length.
Yes, sir.
Maximum length. So I will say this norm P is known as maximum length of all of these above all of these above subinterval. What does it mean? Suppose you are here, the maximum length will be x1 minus x a. It means that the maximum length of this your maximum length is this interval. So in this case, your non P will be equal to what? X1 minus a. Understood?
Yes, sir.
Okay, so what I am taking, I am collecting all the length of this sub interval, and I am seeing which one is the maximum length, and whatever it is, okay, whatever it is, I am giving a name of that particular length as norm P. Okay, so what it means? It means that the maximum length of all of those interval, whatever those sub interval, whatever I got from partition. Understood? Everyone understood?
Yes, sir.
Yes, sir.
Okay.
Yes,
Observe here, as this norm P will go to 0, as the norm of P will go to 0, and the distance between every like the length of each and every sub interval will go to 0, because this is the maximum length, right? What I am saying, if this maximum length will go to 0, the length of all those sub interval will go to 0, right? Because this is the maximum and this is also going to 0. Let me see. Suppose you are standing here. Okay. There is one moving gate. Moving gate. Okay. This gate will move up to this direction and this direction. And here will be some ball. Now, if this moving gate will go to this direction, suppose this is here. Okay. So your distance is also less than here. Now, if this moving gate will go to zero, it means that the distance between this ball to this gate is becoming 0. So you have to move here like this. Now, the distance between your and that fixed ball will be going to 0, as this gate is going.
Sir, your voice is cracking.
This fixed ball. Right?
Sir, you are not audible.
Am I audible
properly,
now? Just a minute. My internet connection is honest. Just a minute. My internet connection is weak.
Now is okay.
Wait. Now it's okay? Okay,
Yes.
fine. What I am saying, if this is a moving gate, this moving gate will go to this side or this side, whatever it is. And I am standing here and I don't have any way to go anywhere. Okay. And here you have a fixed ball. Fixed ball. Fixed wall. Now, if this gate will move like this, it means that the distance between these 2 points is going to 0. These two walls. Then the distance between me and this wall will go to 0 automatically.
Sir.
Right? Similarly, I am saying this is your maximum distance, as this is your maximum distance. Now, I am saying this distance is going to 0 for some different partition. For one fixed partition, the distance will, this non P will be same, fixed. Okay. If I will take more and more partition, the distance may be increase, may be decrease, right? Suppose
yes, sir.
Someone will come, suppose you have an interval 0, 1, and someone will come and he will say, take a partition 0, 1 by 2 and 1. Now, for this case, this is a uniform distributed partition. For this case, what will be your non-P? Your non-P will be half only, right? Right?
Yes, sir.
Now, if someone will come and he will say, now take this one. What will be your non-P? For this case, non-P will be 1 by 2 only. right?
Yes.
Because
Yes,
this
sir.
is your maximum distance. Now, if I
Yes.
will put one more part here, 3/4,
Yes, it is.
it will become 1/4. So for different partition, the norm will be different, right?
Yes. Yes, yes, sir.
That observation you got.
Yes,
Now
yes.
I am saying I am taking some partitions such that some collection of partitions, say some sequence of partition P1, P2 up to Pn, this. Some sequence of partition. I can take sequence whatever I want. I have already told you, right? In the last class, whenever I was explaining that sequence part. Have you attended the session or
Yes, sir.
not? Okay, so I can take sequence whatever I want. So I am saying just take a collection of partitions such that the norm of that partition is going to 0 as n going to infinity. That is my assumption. Okay, this is going to 0 as n goes to infinity. So observe that this is what your maximum length of subinterval. So if I will take this non-p and it will go to 0, the length of each and every subinterval will go to 0, right? Because this is your maximum length. And what you are saying, sir, the maximum length is also going to 0. So all are the length are lesser than this length, na? So they will also go to 0.
Yes.
This is one
All
motivation.
the
Now,
all the sub length is under this length is
exactly,
big
or
length.
the bigger length is going to 0. So all the sub length will go to 0 because all the length are less than or equal to this length. Now,
And
what I am saying, suppose now you have you know what is the concept of this partition and all, so you can solve easily. You have this curve, and I am saying this. I am saying find the area of this particular region, this region. Initially, if you don't have any idea about integration and how to calculate area and all, but you know how to calculate the area of rectangle. Suppose you are living in an ancient time, but they know that thing. If you have some rectangle, so you can calculate the area by A by B, A into B. Okay, that thing you have. You know that thing. Now, for this case, how will you calculate? So some like I'm assuming that most of the person has lived once in a time in a village area. So whenever some issue was there will be some panchayat kind of thing was there, right? Then all the persons will meet together and try to resolve that particular issue and that particular problem, whatever it is, right?
yes, sir.
Yes, sir.
Now I just want to purchase some land. Okay, I want to purchase some land. And the land is looking like this. Okay. Now, I went to the seller. And the seller told me that I don't know the area of this, but I will charge 10 lakh to 10,000. Okay. 10,000 because I am not that much rich. So, this is 10,000, right? No.
Yes, sir.
1 lakh. 1 lakh. This is 10,000.
Yes,
No,
sir.
this is 1,000. This
No,
is
sir.
10,000. Okay. Fine.
1 crore, sir.
Both are 10.
I'm not that much rich now. That's what I'm saying. Okay, this is 10,000. Okay, so he's saying I will charge you 10,000 rupees. Someone will not tell me, okay, $10,000 USD. Okay, 10,000 rupees per acre. But he don't know how much acre this land is. Okay, unit per unit or per acre, whatever you want, you can take. Now, I went to the seller and I told, please calculate your area of your land and so that I will give you the money. he don't know the actual area of this land. So someone, the wise person, will come to us and he told me, thus subtract this area into small region. Okay, divide this entire land into a small region. Okay, this kind of region. This is the straight line. Okay, this is not looking like a straight line. And what he is suggesting? He is suggesting take this, okay, not this. What I am doing, understood? Okay, let me increase its tangent so that it will be easily what I am saying. What I want to say, I am just saying, okay, he just tell me divide this entire region and do this thing. And this thing. Now, if you are able to see, this thing will become, this entire thing is becoming a rectangle, right?
Yes, sir.
It's a different rectangle, right? Now, you know this distance, you know this distance, you know this distance, you know this distance. So you can find each and every area of every rectangle, right? You can find this rectangle, area of this rectangle, you can find area of this rectangle, area of this rectangle and all, right?
Yes, sir.
Right? If I will add all those area, approximately I will get this area of this land. There will be some difference, but let's not consider this. But I will get some approximate area of this particular region, right?
Yes, sir.
But at this type of moment, I will be angry because I am paying extra charge of this particular areas.
Yes, sir.
Right? I will be angry because I am paying this extra charge. Okay, then some another wise person who is influenced by me, he told me that you have this reason. He told me that okay, no issue. He suggested that no issue. What you do, you will take this one. You will take this reason. Okay. Now here also you get this reason, the rectangles,
Yes, sir.
right?
But their honor was like
in this case, seller will be agree.
Yes, yes.
Now in both of the reason, but that is the like jokes apart. What I am saying, where is it? I am saying, you just observe here. In both of the cases, if I will reduce the distance of this. I will get some, the area, whatever I am calculating will be more preciser than the previous one, right? If I will take this reason. Now I will distribute it. Suppose at what time I distributed in the k parts. Now I am distributing in the n parts where n is greater than k. In such cases, the area will be more precise.
Yes, sir. Like first we find the area of rectangle.
More accurate.
Yes.
Right? It will be more accurate, because what I am doing, I am taking the I am increasing the distribution part. I am increasing that particular partition. So what it will be, this error will be going to 0, right? In this case, the error, if I will increase this number of lines, the error whatever I am getting here, this will be decrease. The error whatever I am getting, this one, this will be decreased. If I will put this line here, this line here, this line here, this line here, and this line here, right?
Yes.
So if I will take this point x1, x2, x3 up to xn, so what it is? It is also a partition of this 0 and 1, right? Right?
Yes, sir.
So what I am essentially doing, if I will increase the number of this element in the partition, the area will be accurate, more accurate than the previous one, right?
Yes, sir. Number of partition is.
Yeah. Now my question here is, which one I have to choose? This undercover agent or this overcover agent? Whatever I have to choose. Which one I have to choose? You have if you will choose this one, then seller will be happy, I will be angry. If someone say this one, then seller will be angry, and then I will be happy. Now Riemann think what will be the solution of that particular thing. Okay, so someone will another person will come to me, sir, how to find for each subdivision. Okay, I will let you know. Okay, how to find for, okay, this one I have already taken, I guess. Yeah. Okay, so someone will come. He told me that, sir, take the partition, whatever you want, just take it. I will not say anything. Okay, but take this rectangle. Sorry. Now someone is coming to me and he is saying, sir, you don't need to do anything. Just take a midpoint of this one, and take this. Take midpoint of this and take this. Take midpoint of this and take this. Now here you are saying, here you are paying the extra money. Here you are getting some free land, right? Right?
Yes, sir.
Now in both of the cases,
both person will happy.
Just a minute. In this case, both person will be agree. That thing I am assuming right now. Okay, but yeah, they will be happy. I will say, yeah, I am getting some extra land and for charging some extra money, and he will say, yeah, I am getting some extra money and giving some free land kind of thing. So both the party will be happy for this by this manner, right? Right?
Yes, sir.
Yes,
okay. That is one of the concept where you can take. So now from this part where I was taking the upper part, this will known as like upper Darboux sum. This will known as lower Darboux sum. Okay, Darboux sum, what is it is that is not in your course, but I am just telling you in a knowledge. In this case, what I have taken the upper part, and if I will take the sum of all those rectangles, then this will known as upper Darboux sum. For this case, if I will take all the sum of all the area of the lower part rectangle, then this will be known as lower Darboux sum. Okay, this is one of another thing that you have taken. Now here, if you will see what you are taking this upper part x1, x2. So you are taking this one, this you have. Now if I am taking this upper Darboux sum, suppose this is your x0, this is your x1, this is your x2. So what you are taking? You are taking fx1. Suppose this function is your f. This function is your f. So what you are taking for this length? You are taking fx1. For this length, you are taking fx2, right? Right? And you are getting this one. So in this case, you are taking this one. So this one known as upper Darboux sum. If you will take the length by right person. Now, if you have partition this x0, x1, so you are taking functional value of this person or functional value of this x1. So you are getting upper Darboux sum. For the lower Darboux sum, what you are saying? What you are taking? You are taking this. So in this distance, you are taking only this distance, right? For this reason. So for those case, if your x0 is this, x1 is this, x2 is this, so you are taking fx0 and fx1. It means what? For an subinterval x0, x1, you are taking functional value of this side, this person. Here you are you have taken the functional value of this person. Here you have taken the functional value of this person. So someone will come to me and he told me that why you are taking the functional value of this x0 or this x1. You can also take a functional value of midpoint of this particular element, right? This two element. Someone can tell me na like that, right? That thing I have taken here. I have taken midpoint of these two and taken the what? And I have taken the length. I have taken the functional value x0 plus x1 by 2 of this and then calculated the area. Okay. So what I have seen till now, I have seen upper one when I will take the functional value of this side, the right hand member of that partition. The lower sum when I have taken this person, the mid person, or I don't know exactly the name of this midpoint or something is. I don't know. I am not getting right now. What is it? Okay. So in this case, I have taken the midpoint. Now Riemann has come to me. Sorry, not me, but he came and he told me that, not me. He told that why you are taking like this. He just told that you are doing the partition, right? So he told why you are why you are taking this kind of thing. You can take any point x star from this x0 to x1, any point from here and take the area of that rectangle and then calculate and then sum all the rectangle and you will also get that particular thing. That thing we can also do, right? If I will take arbitrary point x1 star from here and x2 star from here, I can take this one also, right? Right? Right?
Yes,
Hello?
sir.
Right? I can take that kind of thing. So that thing Riemann has told. So what Riemann has told? Riemann told that take a partition. Suppose you have an interval AB and take the partition P, x0, x1 up to xn. Okay, where x0 is your A, xn is your B, and what? All the xi's is coming from this, in between this, and xi is less than xi plus 1. Increasing order. This thing will be in an increasing order. These three things will be there for the partition. Okay, and then he told that take a sum s. Okay, such that what sum? Just add the area of this. So just take fx1 star into distance of x0 minus x1, x1 minus x0 plus fx2 star into x2 minus x1 and fxn star into xn minus 1, where xi star is coming from where to where? xi minus 1. Understood? Understood?
Yes, sir.
What is this? This is the area of this small region. This whole thing and this whole thing. I have just add all the area. I will approximately get the area of this region, this entire region, right? So that thing I have done. Now here this thing is looking like an odd kind of thing. So I have renamed it and I am saying, yeah, take this as del x1, take this as del x2 and del xn. So for that you will get an area like this, fx1 star into del x1, fx2 star. This is the representation that you have, right? Del x2, this one or this one? This one, right? Hello? Hello?
Yes, sir.
This one, right? Capital X1 and up to this. Now this thing can be written as like this. I is going from 1 to n. fx1 is fxi star del xi. This thing you have already seen, na?
Yes, sir.
See? SP. Understood? From
Yes, sir.
here I have covered. Okay. Now define an integral of f from a to b defined as like this. Now what is this? Just a minute. Okay. So what does it mean? This is just a what? This is just a representation. This is just a representation which is showing as this. And how I got this representation? Can someone do someone has any idea about it? How I got this representation? I think this is in your 12th standard. If you have taken mathematics as your choice of
Integration.
interest. Yeah, this is a sign of integration, but how did you got that? Actually, on that time, what I am doing here, I am doing some, no? Right?
Yes, sir.
I am doing some here, sum of areas of sum of area of some rectangles, right?
Yes, sir.
Right? If I will take this as and stretch by this manner and this manner, you will get this sign.
Yes, sir.
So the motivation of this sign is coming from this sum or as this s. Okay. You can read about this in your 12th standard. It will be there. Okay. Now, what it means? What it means? Fx dx. Here there is some mistake. Here norm p is going to 0. Okay. Okay. Here norm p has to be going to 0. Or you can if you have some uniform distribution, it means that the distance between these 2 points, all the subinterval is same. If the distance between all the interval is same, then you can also write it as n tends to infinity. Okay, that one thing. So what it means that what he is doing, basically what he's doing, he is increasing this point. He is increasing this point. I have already told now where for different partition P, your non-P will be different, right?
Yes, sir.
That I have told. So I am taking those partition, sequence of partition for which this Pn is going to 0. I have told you, you can take a partition like this. There it is. Like this, so that this thing will go to 0. Now, according to Riemann sum, whatever partition I have, I can calculate the Riemann sum, right? Right? If someone will just woke up from its sleep and he told, now, sir, I am giving you this solution, this partition. Please calculate me the Riemann sum for that particular partition. I can do that thing by this manner, right? I can do that thing.
Yes, sir.
Right? So now I am giving a one restriction that I am taking those partition. There will be uncountably many partition, right? You can take any partition, whatever you want. So I am taking a sequence of partition for which Pn is going to 0 as n tends to infinity. What is Pn? Pn is maximum length of subintervals for partition Pn, right? So I can take those partition for which this norm will go to 0. For that I have taken. So what I am doing, I am essentially increasing this extents. I am increasing this extents for which if I will increase this extents, if I will just taking smaller and smaller and smaller and smaller and smaller and smaller, the error what I have got, I have getting this error. If I am getting this error will be decreases slight. If I am if I will increase this point x1, x2, xn, it means that I have taken this one as well. I have taken this. So I will get area more in a more accurate way. So essentially what he's saying, just take a partition like this, and he's saying it means that this is just a representation which shows as area, and it means that take partition P as with P goes to 0, what? S of P, your Riemann sum. Okay, or you can say like that, limit norm of P goes to 0, summation of fxi star del xi. Understood up to this? Everyone?
Yes, sir.
Yes, sir.
Okay. Understood the
Yes, sir.
concept of Riemann? Okay.
Yes, sir.
Up to this, I have covered till now. Okay. Now, what is antiderivative and all? I will see. Okay, this is the slide. So what it is saying, let f be a function defined from a domain D in R to R. Okay, f is any function which is defined from D to R. An antiderivative of a function f is a function f defined on this domain only, such that if you will take derivative of this function, you will get this fx for all x belongs to it. What it is saying? What is antiderivative?
Integration.
What is antiderivative? Antiderivative is saying, suppose you have a function this, you got another function capital F from this D to R, such that if you will differentiate this function, and you are getting this for all x belongs to D, then this f will known as antiderivative of fx. Why it is knowing as antiderivative? Can someone tell me why it is known as antiderivative?
It is inverse of the derivative.
Exactly. It's a inverse operation of derivative, different derivative. Okay. You have this
Yes,
f
sir.
prime now. This f prime. I am saying this f is a inverse, is a antiderivative of this f prime. So what it means? I am performing some operation in this f prime, and I am again getting this f, and this f prime is what? This f prime is a derivative function of this f only, right? Right?
Yes, sir.
So what I am essentially doing, I am performing some operation, whatever it is, I don't know, and I am again getting this f. It means that this is reversing that derivative property, reversing that derivative operation, right? That's why it is known as antiderivative, because it just looking like a inverse of this derivative operation. Okay. So what antiderivative is said? Antiderivative is said an antiderivative of a function f is a function f defined on domain such that if I will take differentiation of this function
Sir,
f, I will get this f. Yes.
Antiderivative means f differentiate and f of x not is equal, then the antiderivative, no?
Sorry. Can you repeat it again? What you
Fx
are saying?
inverse f dash x
fx
and f dash
inverse
x differentiated, yes, equal to f
f.
of x not equal to.
This one you want to say?
No, this one f inverse
Yeah, this is f inverse, right?
yes.
Yeah, you are saying f inverse what? F inverse what?
Suppose
What I am saying, listen, what I am saying, this is looking like inverse of derivative operation. Why I am saying this is operation? Because I don't know the derivative operation is a function or not right now. Okay, right now I don't know it's a function or not. That is why I am saying this is an inverse of derivative operation. Till now I don't know now, whatever it is. I need to check. That's why I am writing here in inverse of derivative. It's looking like an inverse of derivative operation, because if I have f and after derivative I am getting this f prime. So if it has an antiderivative, it will what it will do? It will directly go give me this value f if I will perform the antiderivative operation. Understood?
Can you repeat, sir, one time?
I am saying, suppose you have f, right? And
Yes.
you are performing derivative operation and you are getting f prime. So for this f prime, this f is known as antiderivative of f prime.
Yes.
Suppose here, what I will say, Suman is the mother of mother of Ramesh. Okay. If I am talking about in point of Suman, so what in point of Suman, sorry, in point of Ramesh, so Ramesh, so Suman is a mother of Ramesh. But if I will shift my point of view, and if I want to talk in point of Suman, so Suman will be so Ramesh will be son of Suman, right?
Yes.
That kind of thing is happening here. If this is the derivative of this, then the front one will be a antiderivative of this. Okay, but this thing I am saying in a way you can see, right? There will be some example where your antiderivative will not exist. Okay, or your antiderivative will exist, some kind of thing. There will be some example where function is not differentiable, but it still it has antiderivative.
Okay, sir. Okay.
And that is why I am saying it's kind of this. So for this function fx, this capital Fx is your antiderivative. Why it's so? If you will derivate this, if you will take f prime, what you will get? Add into this up to this. So this function you will get directly, right? Are you able to see?
Sir, f dash of x differentiate is 7x to power 6, but derivative is x to power 8. Example antiderivative.
What I am saying? I
This,
am just
this.
saying you have this example. So
Yes.
an antiderivative of fx is this. So if I want to check this is its antiderivative or not, I have to take derivative of this function. And if I will get this function, then I will say, yeah, this is the antiderivative.
Yes, sir. Yes.
That thing I am saying, I
Yes,
can
yes,
say.
sir.
But
Yes,
here
sir,
you
sir.
can see, because of this constant c, I can easily see this fx, capital Fx is not unique.
Yes, sir.
Right? If I will put in place of one C1, in place of a C2, so I can take, I will get infinitely many antiderivative of fx if antiderivative exists. Understood?
Yes, sir. Okay, I am understood.
Okay, so here is one fact: f is an antiderivative of f. Then so f1x is equals to fx plus c, where c is any constant that is a real number. In fact, every antiderivative has this form. Okay, because of this we will use the instead of n. Yeah, because of only we are using n instead of d. Otherwise if it will be unique, then we will say the antiderivative. That is why I am saying here n, because it does not have finitely many. It has infinitely many. Okay, so here are some antiderivative and integrals. What is the connection behind it? So the antiderivative for a function f is more often called integral. Okay, this antiderivative is known as integral of f. Understood now? From where this integral term is coming?
Yes, sir.
Yes, sir.
This is just the name of this antiderivative function. Okay.
No, not any value.
If you will
Because,
perform
sir,
this antiderivative
integration,
operation, it means that you are performing that integral operation. It's just a name, just like my name is Arpit. Like now, suppose when you newly born and you did not have any name, your father will like your family members, how they will call Chotu kind of thing, or Lalla kind of thing. There are so many names. There were so many names, right? After admission, after getting admission in first class or two class, they will give you a professional name, whatever you have. Just like my parents will give me Arpit. So it's just a name.
Yes.
It's looking like a long, it's looking like some ugly kind of thing, that anti-derivative. Instead of this, they suggested that just call it integral. But there are some reason behind this particular terminology. You will let you know later if you will learn more
one
of.
small dot, sir. Integration based solve the method by substitution method, yeah, by parts method.
See, it
Depends
depends on the
question.
integral. It depends on the
It's a type
integral.
of integration, bro.
Yeah, it depends on the integral. No, what you are saying, you are saying what is the best way to solve the integral? Either it is what is it? It's a Bipart method or it's a substitution method?
Yes.
See,
Yes.
it depends
Part.
on the integration. Okay, it depends on the integration.
Okay, rule regulations.
Yeah, no, not rule regulation. I'm saying
some
it just
function need
depends
to-
on the integration.
Actually,
Whatever you have.
12th mathematics study in times 746 rule.
Okay, they are just rules which are defined for integral. Okay,
Yes, yes.
this operation is following some linear property and all that kind of rule was there. But I am saying if you want to choose any of the method from integration by part or
Yeah, by
substitution,
parts.
then what will you choose? That kind of question you want to ask, right? So I am saying it depends on the function, whatever you want to integrate.
Suppose, sir, integration integral 0 to infinity sine x.
Just a minute.
0
Sin
to
x.
infinity sine x into cos x.
Cos x.
Yes, and dx.
So what I will choose? Firstly,
Yes.
I will convert this like this. I know not 2 sin x into cos x is what? Sin 2x. Because if you will go to integration by part, it's difficult because this thing will not be erased. Whatever step I will take, this thing will not be erased. So I will just use my common sense
just
and then I reduce it
2
by
sin
this.
x, 2 sin x into cos x.
Yeah.
Okay, equal to sin 2x.
Yeah, that thing you have already learned in week 7 or week 6, right? I guess.
Yes. Suppose, sir,
Just a small
sin x, t and this type method, another method, q and v types.
We will discuss it, okay? Because
And,
I just
okay.
see, we'll discuss about this integration and all. Firstly, I will finish this one.
Okay.
Now, because if we don't have that much time, we have to finish as soon as possible. Okay. So the fundamental theorem of calculus, what it is saying? It is saying, suppose f is a continuous function. Remember that f is a continuous. On the domain D, which includes the interval this, you have interval, you have f as continuous function, you have domain D. Then an antiderivative of f on AB is given by this. Okay, this is a definition of this. How will you calculate? You have the method of calculating this, right? That Riemann sum method. That this is also one method, right? Solving. Here is it. This one you can calculate by this manner, right? I am saying you can calculate, but you don't need to calculate by this manner. This is a tougher side. You don't need to calculate. We already have some basic formula so that we can easily calculate it. So you can calculate your fx will look like this. What it's saying, if you have f as continuous function, then if you want to find the antiderivative function, then your antiderivative function is look like this. You can directly calculate by this formula fx. It means that if f is not your continuous, f is not continuous, then there may be possibility that your antiderivative is exist, but you cannot find this antiderivative function via this integral. Okay. So what I am doing, what I am saying there are some function who has antiderivative, but they are not integrable. Okay, that is why he is saying if f is continuous. If f is not, then okay. So just go after this class. Just go to the Google and try to find some example where antiderivative is exist, but your f is not what f is not integrable. Okay, that is your homework.
Okay, sir.
Okay. Conversely, if f is continuous on the domain D, includes the interval this, and f is indefinite integral of f, then the definite integral, definite it means here x is not free, x is variable, but here you have fixed that x, okay, by b. Okay, that is the difference in both statements. Then your fx dx is look like this. Understood this one? This is just the theorem. Okay, you can read it. Understood?
Yes, sir.
Understood? Now some tables of derivative and integration, that thing you can easily see, I guess. This is of some formulas kind of thing.
Yes, sir.
You want me to solve this example or not?
Can you explain the part, integration by
Hello?
part and
Which one, sir?
substitution?
Hello?
Hello, sir.
Do I solve this example?
No, sir. No. So take it out now.
This one you can see, this table you can see, right?
Yes, sir.
If you
Yes,
want,
sir.
you can take screenshots. Or I guess this PDF are available.
PDF is available. Can you explain the portion of that integration by part and substitution?
Okay.
That's all.
Okay. So you want me to solve this? You can directly apply this formula.
Yeah.
This formula. You can get.
Yes, sir. We can solve it.
Okay, you will solve it. Okay. What is next slide? Computing integrals. Okay, how to find integrals and areas. Okay, so this is your fundamental theorem, integrals and in Newton. So what it's saying? It is saying the integral fx dx of function f is defined on the domain. A function f is defined on the domain is known as, this is your definition of antiderivative, right? And if f is continuous, the domain is look like this. This is your fundamental theorem, right? Whatever I have done. Now observe, if one knows the integral of a continuous function, then one can use it to compute the area between the graph of the function of an interval on the x-axis. Okay, then we will see how we can calculate by using the integration. As I already mentioned that thing in that exam here when I was explaining that things. Okay, so if I can calculate by this integration, by this area by integration, then this sign will make sense, right? Right now I don't know what is this sign. Okay, but that theorem is saying कि I can calculate the area by using the integral. Okay. Hello.
Okay, sir.
Okay.
Hello. Okay.
Yes, sir.
Yes, sir.
So this sign will make sense, right? This both thing, calculative sign will make sense. Both are same. Both are looking like same, right? So this sign will make sense, right?
Yeah.
Okay. So this is just the intuition. Okay. So basic properties of integral here, you have some basic properties, some linear properties kind of thing. Just remember this this all the properties, because this is very useful for your future integration part. So this all the properties are very useful. Okay, so please recall it. Okay, here one is if you have CF kind of thing, your constant will not be participate in the integration, that kind of thing. You are it is linear under addition, linear under what subtraction. Yeah, this is your integration by part property. And here you have some property A to B CF kind of thing. Yeah, both are same. Here if you change the limit, so you will get minus of this. for any C belongs to R, you can split it like that. But the condition is, here he did not mention the condition. The condition is A is less than C is less than B. You have to mention that. Okay, so what fx is greater than, yeah, this is obvious now. Why? Suppose this is your fx and this is your gs. This is your fx, this is your gx. Okay, so what it is saying, if fx is greater than gx, okay, so this is your gx, sorry, fx, and this is your gx. Here fx is greater than gx, right? Right?
Yes, sir.
Okay,
Yes, sir.
so the area under this fx is greater than area under this gx.
Yes, sir.
Okay, that's what he's saying. Here he just want to calculate some example, and also this thing will solvable by integration by part. Okay, here no substitution will work. See, in this example, there is no way you cannot substitute anything in place of this so that you can easily solve the integral. You have to use integration by part only. Understood? Okay. Understood? Someone was asking that thing now. What will I have to choose? Okay, integration of piecewise defined function. Okay, how will you break? So how will you integrate it? See, you have to integrate 0 to 2 fx. Now, your fx in this interval is defined as like this. Your fx in this interval defined as like this. In this interval defined as like this. But you have seen now, if you will take any point between 0 and 2, you can split by this property. Here is it. This property, you can use this property if C is coming from A to B, between A to B, you can, this area is same as this splitted area, right? So now you can use this property here. Here, your fx is defined in this interval and 1 like this, and now here you can split it like this, 0 to 1 fx dx plus 1 to 2 fx dx. That thing you can do, right? Right? Via that property. Now, in 0 to 1, fx is defined as like this. And at 1, between 1 to 2, your fx is defined as like this. So you can put the value and then calculate the integral. Now here integration, uses of integration by part. Here you have example, you can solve that integration. I don't need to solve, right? Hello? Please someone unmute yourself and then please let me know. Otherwise I will solve that. Okay, he's at here substitution. Substitution means all of you aware of it. Here, if, how will you solve this integral?
Yes, sir.
You can substitute u as some sin s kind of thing, and you can calculate, right? A sin x kind of thing. So this is your substitution method. Now there is no way where you can learn what thing I have to use. That the only way is you have to solve as much as integration you can. Okay, this thing will come only whenever you will practice more and more and more. Okay, then only you will be master of that interval. Okay. Okay, so back to the computing areas. Here we will compute. Now, if you want to find the area of the circle, so how will you find? How will you find? You have area, you have this circle, and if you find area of this circle, so how will you find? someone will come to me and someone tell, sir, I can find area of circle easily. How? I have nice formula pi r square. If I know the radius, I can easily find by this. What if I will say you don't have radius? But you need radius. What if I will say, just prove it? How will you prove?
So we integrate the perimeter? No.
So what I am saying, you have an equation x square plus y. This is the equation of a circle centered at 0 and whose radius is a. Okay. So I can easily find the value of y square, which is this. Here y you can find. Sorry, x square. Here plus minus will be there, but I am just considering the plus part. So I am saying plus part, you are this one, na? This whole thing.
Yes.
So what I am saying, if you will calculate area of this one part only. What I am saying if you will calculate the area of this one part, and if you will take a 4 times of area this, you will get that particular area of whole circle, right?
Yes, sir.
So what he did, he also did. You have the equation of what is known as circle. Now he has find the value of fx, this one. Now he find the area a. What he wants to integrate, he wants to find 0 to a fx dx, which is equal to pi a square 4 by 4. Now you have to do 4 times of this, then you will get this area. Understood, everyone? It's easy, not so tough. I remember that thing when I was in 12th. I firstly, what I have calculated the area by this method. I have calculated this by this example only. Okay, so that thing is cover your week 9. Now, after that, you have some doubts from practice assignment. Some person has sent me, right? So I am taking that one by one. Okay, if someone has no doubt, they can leave the session. I will close this session by 10:30. Okay. If you guys don't have any doubt, you can leave the session. Okay.
Hello, sir. I have sent in chat, sir.
Yeah. I'm taking that.
Sir, Arpit sir.
Yes.
Sir, question, how type question, sir? Example, exam, sir. Which type question? Mostly.
In this part, they will ask, they will give you the function like this, and they will say, just calculate the area of that particular function.
Actually, most question, I think, mixing concept, 2-3 concept, mixing one
Most
question.
of the questions, see, you have covered week 1. Sorry, you have already done quiz 1 and quiz 2, right? In my exam, what they will essentially do, they will ask some portion from in quiz 1. They will ask some question from. They will ask some questions in quiz 2. Like you have whole syllabus. They will distribute it into 3 parts. Okay, this part for quiz 1, quiz 2, and this is end sem. So in the end sem, majorly questions
Sir,
are
one
coming
question.
from here.
Suppose quiz 1 is a finance and quiz 2 is a lower end semester total, no? Yeah, quiz 2 is a lower mark, eligibility criteria according.
See,
then the final.
In the end semester, major portion will be coming from after quiz 2. Okay.
Oh.
The major weightage is coming in the IIT Madras. This rule will follow. Okay.
Oh.
They will ask you major question from after the quiz.
So offline is same process, yeah, and different, sir.
in the online, I am expecting that there will be some same process kind of thing. Okay, I don't know the exactly in IITPS program, but yeah, you can ask to your seniors now. Or
Actually, Professor sir, Professor Anirudh
see,
sir, according to offline and online QS assignment, this type
yeah,
exam.
they will ask question like that only.
Okay, sir.
Okay.
Okay, sir.
So
Thank
what this question is saying, see, what I am expecting, I am saying majorly questions will be coming after quiz 2 in end cell. There will be some
Okay.
question they will ask from quiz 1 and quiz 2, but major weightage will be after quiz 2 portion only. So you have A be a set of local minima, B be a set of local infima. So basically what you have to find. Did I cover that second derivative test? Yeah, that thing already covered someone, right? You have you have already done that course like that portion, right?
Yes, sir.
In yesterday's class. Now you have this function, and you need to find the set of local minima and set of local extrema. So first derivative is test is saying just do derivative of this. How will be 4 times x power 4 divided by 4 minus 3 into 2 x plus 2 into 11 by 2. Yeah, here x square is minus 6. On this 4
I think
becomes
it's
11.
x
It's
to the
easy,
power
na?
3.
Where? Yeah, it's x to the power 3. So what we will get? We will get fx is equals to x cube minus 6x square plus 11x minus what? Minus what? 6. Now, see, if you are a little bit clever, you can easily see in each option 1, 2, 3 are there. 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? It means that 1, 2, 3 will become your critical point. That is definitely this point will become your critical point, right? So you don't need to find the roots of this, because at least one answer will be correct, right? One option will be correct. And this A is what? Set of local minima. And this B is what? Set of local maxima. It means that A and B are containing critical points, right?
Yes, sir.
Yes, sir.
Means that your critical point will be 1, 2, and 3, right? Right? Or you can calculate, you can take like you can find out the roots of this function, and you can calculate. Right now I am observing from here. You can easily take the roots, right? By hit and trial method. You can find roots.
Yes, sir.
Okay. Now these are all your critical point. Now you need to find which one is your which one is your point of local minima, which one is your point of local maxima. So you need to find double derivative. What it will be? 3x square minus 12x plus 11. Now put 1 by 1 here. Just find this. Now easy, na? If if f double dash of x naught is less than 0, then it will be your point of local maxima. If f dash of x naught is greater than 0, it will be your x naught will become your point of extrema. Sorry, minima, right? The
Yes, sir.
double derivative. So just find out this value and then see it is a negative or positive, and then you can decide your A and B. Easy.
Yes, sir.
Mr. S. Is here or not? Now, one more question is there. Okay, what is the maximum value of this function? Are you able to find? How will you find? Firstly, take f prime, then see how many roots are there, then find the roots, and then take f double prime and put the see the maximum see the value. Is there any interval?
Yes, sir.
Yeah, there is some interval. What is it? Can you someone tell me what's the interval? Huh?
0 to 3.
0, 3, right? Now, what you need to check? Firstly, find all the critical points of this. What your f dash is what? 3x square minus 4x
Minus
4x
3.
minus 3. So, what will be your roots? Huh? 3, 3s are 9. X is equals to what? Suppose your root will be alpha and beta. You can find by a quadratic formula. It will take some time. That is why I'm not finding. Okay, and then see which alpha, if alpha, which one is in between this 0 and 1, 0 or 3. If there will be alpha, if suppose alpha is there, alpha is coming from here, then you need to calculate f of alpha, f of 0, and f of 3. Okay, and then see which one is your maximum value. This one, or this one. Whatever it is, that will become your maximum value. Okay. Why so? Suppose this is your function and -1 to 1 your interval. If I will say what is your maximum, so you are getting maximum at -1 and 1 only, na, right? If I will fix the interval, then you will get value like this. This will become your maximum, right?
Yes,
That
sir.
is why you have to see the value at endpoint as well. Understood? Mr. S, are you there?
Hello, sir.
Are you there, Mr. S? No, right? Okay. Mr. S is not there, so we will not take his doubt. Some Netra, are you there? Sorry if I am pronouncing your
Yes, sir. Yes,
name.
sir. No, Mr. S has said a message that his mic is not working.
My mic is not working.
S has said
S. S is there, right?
No,
Okay,
sir,
okay.
sir,
Okay, okay.
your voice, sir, your voice is very nice.
Not your voice.
My voice.
Not your voice.
My voice is.
No, the S.
Yes, sir. Mic is not.
If you,
Okay,
if you
okay. Yes, I will take your doubt. Okay. Are you able to see this?
Yes,
What
sir.
this is saying? Which of the following options are correct? If xi star, if xi star is equals to xi, then the Riemann sum is equals to. What is your f? What is your f here? Is there any previous
Sir,
thing?
f of x equal to x in the interval of 0 to 5. and
This one.
it is divided into equal intervals. They have given, I think it is 5 by n. Delta x is 5 by n.
5 by n. Okay. Okay, fine. Okay, so the distance between the sub interval is equally likely by 5 by n, right? Equal distance have each sub interval, right? This is the question. This is the question, if I am not wrong.
Yes, sir. Yes, sir.
So
I
will
did not
explain how
post
will
this
you do.
question, but I think this is the question.
Okay. Okay, fine. So f of x is here, this is equal to x, 0 to 5. You are taking subdivision. This distance is your 1 by n. Now, what he is saying, if xi star, here you are choosing to choose arbitrary point. Now he already fixed the xi star is xi. It means that this point. So this summation, how will you look like? See, your del xi will be, come in front. In this case, one note is visible to all? No. You have fx is equal to x at 0 to 5. And the distance, this is your interval partition, suppose. Each partition has same distance by 5 by n. So he is asking about Riemann sum, fx I star. Into del xi. Okay, he's saying if xi star is equals to xi, then what it will be? Yeah, okay. So he's saying right. Okay. Okay, as you just use chat box. So this is right? So I will explain you the first option. According to that, you can calculate how will you, how can you approach for this question. Everyone is like that only. If xi is, he is giving some fixed value of xi star and he wants to calculate. But in each calculation, you can easily see your del xi is 5 by n only. Because the distance del xi is what saying? Del xi is nothing but your del xi is xi minus 1. Xi minus 1, which is equal to 5 by n, because each sub interval have same length, right? So this thing will become your 5 by n outside, and this is your I is equals to 1 to n fx I star, right? Because your fx I star. Now your fx I star is your xi. This will become 5 by n. Summation I is equals to 1 to n what? Fxi only. Now your fx is defined. Now your fx is defined at like this. This will become. Is clear? Hello. Everything is clear up to this?
Yes, sir.
Now you need to find this value xi.
Can you repeat, sir?
Okay.
Repeat, sir, one time.
I am saying
Step.
I have just put xi star xi in place of xi star. So now your fx is defined as like this. So fxi is equal to xi only. So I have put the value xi here. Now what your task is? Your task is you need to find the xi. Okay. Distance is 5 by n. Now 0 is your x naught. X1 is what? X naught plus 5 by n. Right? X2 is what? X1 plus 5 by n. X3 is what? X2 plus 5 by n. This thing is going on now. Right? Now, here you can put the value of x1. So what you will get? X naught plus 2 times 5 by n. Here you will get x naught plus 3 times 5 by n. Understood what it's going on here? Mr. S. So if you will calculate xi, so what you will get? Xi minus 1 plus 5 by n, which is equal to x naught plus here 3 here, 2 here, for 1 here. So here for this I times 5 by n, right? Right? And what is the value of x naught here? The value of x naught is 0. So xi will become I times
Sir, your voice is cracking.
5 by n. Now, hello. Now it's fine.
Yes, sir.
Hello.
Yes,
Okay.
sir.
So it will become 25 by n square. It will become 25 by n square. Now you have to calculate 1, 2, 3, 4 up to I. Sorry, up to n. How will you calculate? Can someone? I knew that formula, but I want to
n
from
into
your side.
n minus 1 by 2.
N into n plus 1 by 2. Please recheck. Not n minus 1. N into n plus 1. Please check it. Okay, it will cancel out this. So you will get 25 n plus 1 divided by 2. This will be your answer. If it will be n minus 1, then you will get n minus 1. So your this answer is correct or incorrect? Incorrect, right? The first answer is incorrect.
It's correct.
This is incorrect. This one is correct. So similarly, you can get this one and this one. Hello?
Sir, first is correct.
Let me check. Just a minute. Am I audible now?
Yes, sir.
Yes, sir.
Yes, sir.
Hello.
Audible. Yes,
Yes,
sir.
sir.
Audible, sir.
Hello.
Yes, sir.
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
So this
Audible,
problem
sir.
is solved.
Very nice voice, sir.
Okay. Thank you. Thank you. Thank you. Thank you. Okay.
Sir, your screen is not visible.
Yeah,
Sir,
I did not share that screen. Just a minute.
sir, now
Just a minute. Just a minute.
visible, sir.
Netra, are you there?
Yes, sir.
Swarnam? Yeah, Netra is there. Okay. So that this is your doubt, right? What
Yes.
is doubt here? What's the doubt here?
Sir, I'm not able to solve.
Or you are not able to solve this
Yeah,
question.
actually, I
Suppose
substituted
a
this.
wire length is 35. Just a minute. So what it's saying, you have a wire of length 35. Here is one more. Just a minute, I'm not getting that one note here. Okay. You guys are able to see one note?
Yes, sir.
Now, what it's saying, suppose a wire of length 35. You have a wire. You have a wire. The length is 35. Is cut into pieces. One part is bent into a circle. And another will form a square. Okay. Let x just a minute. Okay. Let x be the minimum value of the combined area of the circle and the square. Okay. Then what is the value of 4x pi plus 4? Can someone tell me how can we go for this solution of this particular?
Actually, I substituted one part. If one part is x, other part is 35 minus x. So
yeah,
y
take y because x is already using here. You just take y.
Okay, sir. Y and 35 minus y. If y is bent as a square, then area of the square will be y by 4 whole square. Because y becomes the perimeter of the square, which is
no need to do that thing, right? If this is going to become your circle, this is your 35 minus y. This is your square. So y square sorry, yeah, y square, y is your parameter, yeah. So y by 4 will become your one edge.
Side of the square.
Length of one edge. Yeah. So it will become y by 4 square. Yes. And
likewise,
this is your para.
Yeah, 2 pi r is equal to 35 minus y.
2 pi r is equals to 35 minus y. Yeah, correct. So from here you can find the radius 35 minus y by 2 pi. Right. And next, what is it's asking?
Sum of the two areas will be
Sum
minimum.
of the
Should
two
be
areas.
minimum. Yeah.
Okay. So just do sum. What will be the area of this? Pi r square. It means 35 y by 2 pi whole square plus this y square by 16. This is your fi, new function. Now take f prime y. I'm directly writing. No need to. Your f prime y will become minus 2 pi 35 minus y by 2 pi and inside by 2 pi. Okay, this will become your plus 2y by 16. So here this thing will cancel out. You can take derivative, right? Or I have to explain this. How will I got?
Yeah, I can do, sir. I was expanding f of y all the way and I was trying to take derivative and I'm not able to solve. That's
You
why
can
I was
directly put, you can directly substitute here this
okay,
thing
okay,
as
sir.
another function and then take derivative. Now,
Okay, sir. Okay, sir.
this will become your 5 y minus 30. Now, are you able to find?
Yeah, I think I'll do, sir.
Yeah, because just take y as common and here you are getting only one critical point. So that has to be your point of minimum or maximum, whatever you want. So that will become your answer.
Okay, sir. Okay, sir. Thank you.
Swarnim, are you there?
No, sir.
No, right? The value of this integral dx is $10.39. Okay, we have to calculate the value of this integral. Everyone is able to see?
Yes, sir.
Natra, it is your question. So what
Yes,
you can take? You can take a root x as t and then you can solve. Substitute it by t. Okay.
Okay, sir. I was getting answer as 1, but it is showing me the right answer is 2. That is why I'm very confused.
Maybe there will be some mistakes. Recheck once again.
Okay. Okay, sir.
Recheck once again. This is the simplest question, like simple question.
Okay, sir. Okay, sir.
Activity question. Which of the following is our true? Swarnam is not there, right?
Yes, sir.
Okay, Adarsh Raj is here. Did you discuss that question in your group, guys? Yeah, Adarsh, are you there? No. S, are you there? No. Is anyone here who has doubt? Hello.
Yes,
Am
sir.
I audible?
Yes,
Am I
sir.
audible? Is there anyone who has doubt? Disha, do you have doubt any?
Yes, sir.
Please ask. Otherwise, I will just close the session.
Okay, sir. 1 minute.
Disha, can you take a screenshot and then upload?
No, sir.
You can't.
Yes, sir.
Okay. Let fx be a function. Please make sure that I am reading correctly. Let fx be a function if the function fx has local minima at point 2, 5. So x is equals to 5. Okay. Then, okay, my internet connection is. What is the doubt here? It's easy question, right?
Yes, sir. Can you please draw the graph for this?
Am I audible?
Yes, sir.
Yes, sir.
So it's an easy question. See, if something is your x0 is your critical point, so tangent at x0 will become u0, right? What is your tangent for differentiable function f tangent, right? F prime x. If f is your differentiable function, then f prime x will become your tangent function. And if x0 is your 2, so here x is equals to 2 is your local maximum. It means x is equals to 2 is your critical point. So f prime 2, it means that the tangent or the slope at 2 will become your 0. So this answer is incorrect. Point at 2 is 0 and at 5 is also 0. Okay.
Okay, sir.
Sir, your voice is cracking.
Yeah, actually network connection is very low right now. This are understood?
Yes, sir.
Okay, okay. Okay, I'm leaving the session. I'm stopping the session. You can just leave. Good night, guys.
Good night, sir.
Good night,
Good night,
sir.
sir.
Good night, sir.
Good night, sir. Thank
Good
you,
night.
sir.
Good night. Good night.
Right, sir.